The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is question number 14. Number 14 says a tank of water is mounted on wheels and rolls without frictional loss on a track. Without frictional loss. As the tank moves, water trickles out at a constant rate through a hole in the bottom. The speed of the tank will what? So we have a cart with water in it. There's a hole where water's trickling out, and it's moving along a track at V naught. Then later, at V final, how is V final going to relate to V naught with the body of water inside it a lot less, and water continues to trickle out? Now, first, you want to think momentum conservation. Conservation of momentum, which is M initial, V initial is equal to M final, V final, right? And this initial mass is going to be greater than the final mass, right? So you would think that V initial is going to be less than V final since they have to be equal. That is not the case of this particular situation. Why is that? Well, as the mass is lost, conservation of momentum says it should gain speed because it wants to conserve momentum. However, with gaining speed, you gain with V up, then that means you gain kinetic energy up. How can you gain kinetic energy by losing mass? That is kind of an impossibility. You don't have a force acting on it, you only have a loss of mass. So, if you were to gain velocity, you would have to gain kinetic energy, and you would have to have energy put into the system, not mass lost. So, even though conservation of momentum says that, the conservation of energy is a higher ruling law than conservation of momentum. Now, conservation of momentum is still fulfilled in that the mass of the cart is lost, but all of a sudden it becomes mass initial, velocity initial is equal to, and that's of the cart, the mass of the water and the velocity of the water. The water that fell out is going to have velocity going this way, plus the mass final, the velocity final of the cart. Water, cart. Okay? So you have to think about it like that. Conservation of mass, or of momentum, is kept, but not in the way that not in the way that you would think initially. This is a tricky question.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.